It's our subject for the stereochemistry, and last lecture we talked about S2R configuration, how to find the SR configuration for the stereoisomers. Now, by simple way, if you have like this molecules and this the lowest priority groups like hydrogen, it will be take number 4, yes? For example, the hydrogen. By simple way, you have to put this in the backside, okay? In the backside. So look to the remaining 3 groups, the priority for the remaining 3 groups. If the priority like this, 1, 2, 3, according to the clockwise, that meaning this, it will be what? R configuration, as you said, okay? If the range of the priorities, it will be counterclockwise, it will be like this, 1, 2, 3, that meaning this, it will be what? It will be S configuration, okay? This, it will be S configuration, and this, it will be R configuration. So, some students, sometimes you have a problem if you have big molecules, big structure molecules, or some students, they cannot imagination how the situation, it will be like this. Or if you have the hydrogen here, I just want to make simple rotation, and they cannot write it on the paper, how it will be this simple rotation, it will be happened, okay? So, if I make simple rotation like that, that means the hydrogen will be go to the backside. And this, the group, it will become to replace with the hydrogen position. And this group will be replaced with this group, like that, okay? If you have a problem with the rotation, sometimes with the rotation on the paper, when you answer the question, okay, I will give you another procedure without rotation to find the SR configuration, but without rotation, okay, without rotation. So, what is this procedure? How we can find the RS configuration without rotation? So, step number 1, he said, if you have like this compound, look, what is the priorities for the group? OH, it will be take number 1, because the oxygen atom, yes? CH2, CH3, it will be take number 3, good. And CH3 by 3, the isopropyl group, it will be take number 2, good. And the hydrogen, take number 4. Okay, now I want to put the hydrogen in the backside, to rotate the molecules in the backside. Okay, to rotate the molecules, enter the hydrogen to go to the backside. Now, if you have a problem with rotation, I will give you now procedure without rotation. Okay, without rotation. Step number 1, what is this procedure? Step number 1, he said, switch the position of the lowest priority groups. The hydrogen, for this example, where is the lowest priority group? The hydrogen will be take number 4. He said, switch the hydrogen with the group located behind the page. Any group located behind the page. The ethyl or the isopropyl? The ethyl, good. The ethyl located to the bag in the far side from you, okay, in the back side. That meaning I just switch the hydrogen here and CH2, CH3 in here, and the position. Just switch the position of this 2 group. Okay, if you switch the position of 2 group, what is the configuration? Do you think? This is the hydrogen here, the CH2, CH3 will be here. What is the configuration? It will be 1, 2, 3. That meaning counterclockwise. That meaning it will be what? S configuration. Then, if you said F configuration, now you have to switch your answer also. You said S configuration, yes? Switch your answer. It will be what? It will be R. That meaning the answer, it will be R isomers. Okay? Why we switch the answer? Because you switch the position of 2 groups. You break the bonds and you break the hydrogen and put it here. You break the bond between the ethyl and put it here. Okay? That meaning in this time also you have to switch your answer. To switch your answer. Okay? Now, look this. Switch the ethyl and the hydrogen. Switch it here. What is the configuration? 1, 2, 3. S. S, switch your answer. That meaning the real answer, it will be what? It will be R. Okay? Do you understand? Do you understand? Okay. Now, look. Again, I will repeat it again. By this, okay? Now, I want to find the configuration for this. Now, the hydrogen is with the yellow color. For example, the hydrogen with the yellow color. if you can make rotation like that. Okay, make rotation like that. If you cannot make rotation, I will break the bonds, switch the two bonds here. I put it, the hydrogen, what is the group in the backside? I replace the two groups, the hydrogen with the ethyl. Because you break the bonds, you switch the bonds, also you have to switch your answer. Okay, so if the configuration for this, according to here, 1, 1, 2, 3, 1, 2, 3, the S, but you switch the bond, that meaning the real answer, it will be what? It will be R, because you break the bonds. Okay, now in reality, in the fact, we want to find the configuration for these molecules, but without break the bonds. Don't break the bonds in the fact. But because we break the bonds, also we have to switch the answer. Do you understand now? Okay, this is the procedure. But if you want to make rotation, make rotation. But if you don't know how to make the rotation, you have to switch the two groups and also switch your answer to change the answer. To change the answer. Now it is clear for you? Okay, another example, if we have it here. Now, look the rotation. Here the rotation is easy. 1, this, 1, 2, 3, 4. Where is the 4? 4 here. I want to put the 4 in the back side. Okay? That means just a small rotation like that. Small rotation. Like that. The hydrogen here, in this example. The hydrogen here. Just I want a small rotation. That meaning, if I want, for example, to find for this compound. Yeah, for this compound. We want to resolve this example, yes? Okay. Now, what is the group in this example? What is the group? Now, look. This is which? And this is dashed, and this, and the two plane. Okay. Put the groups CH2, CH2, what? Br. Good. And here, what we have, for example, OH. And here, put CH2, for example, CH2, Cl. And here, I will put the CH3. Okay. Now, what is the configuration of this compound? This compound, not this compound. Okay. Now, this, we have to put numbers now. OH, take number 1. Okay. CH2Cl, CH2Br. Anyone it will be take number 2? CH2Br. Good. This 3. And this 4. Now, where is group number 4? This is the group number 4. For example, this with the yellow color. This is group number 4. I want to put number 4 in the back side like that. Now here to the back side. Okay, just a small rotation like that. Small rotation. Small rotation like that. Okay, make rotation. Okay, now this, it will be the same position. CH2Br, yes? CH2Br. And this, it will be go to the back. It will be come to here, to the CH2Cl. CH3. CH2Cl, it will be come to here, yes? CH2Cl. And OH, it will be here. Put number, this, it will be number 1. And this, number 2. And this, number 4. And this, number 3. Okay, now 1, 2, 3. That meaning what? What this? 1, 2, 3 is R. R isomers. R configuration. R configuration. Now this procedure number 1. If you don't know to make the rotation, go to use the second strategy to switch the groups. Okay. Now this number 4 and this CH2Cl. Yes, I want to switch this with this to put the lower priority groups in the backside. Okay. Just switch this with this group. For example, here. Yeah. This CH2Br. CH2Br. And here it will be what? CH2Cl. And here it will be CH3. And here it will be OH. This it will be number 4. And this it will be number 3. And this, it will be number 2. And this, number 1. Look to the 1, 2, 3 is what? عكس عقرب الساعة. Counterclockwise. That meaning this is. That meaning the answer will be what? R configuration. R isomer. R isomers. R isomer. R isomer. Okay? It will be R isomers. You have also to switch the answer. Do you understand? Okay? You have to switch also the answer. Okay? Clear? Now, for this example, look here again. He switched this 4 with a 3, yes? 4 with a 3. That meaning this, it will be switch the group 4 3. It will be give you any configuration. It will be give you S. That meaning the real answer, it will be what? R isomers. You have to switch the answer also. R isomers. Okay? Now, another example if we have here. Okay, what is the configuration of this compound? Number A. What is the configuration of number A? Already the hydrogen, the lower priority in the backside. Okay, is easy. That meaning 1, 2, 3. Okay, what this S or R? S configuration. عكس عقرب الساعة. Okay, عكس عقرب. Okay, now this example. This 1, this 2, 3. 1, 2, 3. S. Okay. This. Okay, methyl, ethyl, propyl. Anyone will be take number 1? Propyl. 1, 2, 3. That meaning this also S configuration. Okay? Try to find the configuration as homework, this for you. Now, draw both enantiomers. Look here, this the drawing structure here by 2-dimensional figure or 3-dimensional figure? Okay, by 2-dimensional figure. This is the structure. There is no wedge and dashed bond. Okay, this is 2-dimensional figure. He said convert the stereogenic center here to the 3-dimensional figure and draw both the isomers, the R isomer and the S isomers. Both of them you have to draw. Okay, to draw, try to drawing both the isomers that we can found it here in the stereogenic center. This also homework for you. Now, diastereomers. We have now seen many examples for the compound containing one tetrahedral stereogenic center. The situation is more complex with compound that have 2 stereogenic center or 3 stereogenic center. Okay, with 1 stereogenic center, this for example, 1 stereogenic center. Okay, diamond, we take it 1 stereogenic center, no plane of symmetry. It will be chiral or achiral. It will be chiral molecular. Okay, now 1 stereogenic center, there is no plane of symmetry, has mirror image. This mirror image non-superimposable. That meaning it will be what? It will be طبعا chiral, but it will be the name of the isomers. It will be what? Enantiomers. Okay, it will be enantiomers. Enantiomers, mirror image, non-superimposable, chiral molecules. Okay, chiral molecules. Now we go to the new terms here, the diastereomers. What meaning the diastereomers? Okay, so we have now many examples for the molecules that has just one stereogenic center. The situation, it will be more complex if you have 2 or 3 or 4 stereogenic center. Okay, how we can find the configuration, how we can draw the isomers if you have 2 stereogenic center or 3 stereogenic center. Here the situation will be more difficult, but also we have a procedure to find it. Okay, so for any stereogenic center, the maximum number of the stereoisomers, it will be 2 to the n. Okay, that meaning if you have 1 stereogenic center, that meaning how many isomers you have? 2 isomers. If you have 2 stereogenic center, how many isomers you will have? 4 isomers. Okay, maximum number it will be 4 isomers. Maybe sometimes there is less than 4 isomers. Maximum number 4. Maybe some examples, it will be just has 3 isomers, not 4 isomers. But the maximum number of the isomers, it will be 2 to the n. For example, if you have 2 stereogenic centers, that meaning maximum number, it will be 4. Sometimes it will be 3, no problem, less than 4. But maximum number, 4. Okay? Then, if you have a 3 stereogenic center, how many isomers will you have? Why? 3. 3 multiplied by 2, 6 plus 2, 8. You will have 8 isomers. Okay? You will have 8 isomers. Tamam? So, this homework, what is the maximum number for stereoisomers for compound with 3 stereogenic center, as I said to you, with 8 stereogenic center. So, now he said, let's stepwise procedure to find all possible stereoisomers for this example. This example. What is the name of this compound here? What is the name of this compound? 2,3-dibromopentan. That meaning how many stereogenic center they has it here? How many stereogenic center? 1 or 2 or 3? 2. Okay. 2 stereogenic center. Here we don't have a stereogenic center. Here we don't have a stereogenic center. Here we have 1 stereogenic center. Here we have 1 stereogenic center. And the last carbon, there is no stereogenic center. He said, draw the first isomer عشوائي, شكل عشوائي, to put the groups around the bonds. Okay, around the bonds. I will put it like that. So, step by step, this number 1, this switch. Okay, I put the CH3 here, CH3 here, C2H5, okay, C2H5, and then hydrogen, Br, hydrogen. This isomer number A, number 1. This isomer number A. Okay, draw the mirror image for this isomer. Mirror image. Okay, Br, hydrogen, C2H5, Br here, yes, the hydrogen here, and the CH3 here. Look, mirror image. Okay, superimposable or non-superimposable? Non-superimposable. Okay, non-superimposable. Then, chiral or achiral? Chiral molecules. Chiral molecules. Mirror image, non-superimposable. يعني what is يعني in and show Mars. This the first 2 isomers. Easy. Just draw number 1, the mirror image. It will give you the isomer number 2. Okay, I want to draw the isomers number 3. To draw the isomers number 3, okay, to draw the isomers number 3 here is enough. I think here, okay. He said, if you take this isomer, just switch 2 group in 1 stereogenic center. 10 stereogenic center very high. 2 stereogenic center. This 2 stereogenic center. On 1 stereogenic center, just switch the 2 groups. This group with this or this with this, as you want. In this example here, he switched, I think, this with this to the next slide. Also, I want to switch here. Okay, it will be clear for you. You can switch this group with this group, no problem, as you want. Okay, switch this hydrogen with this Br. Okay. Now, here CH3 with this C2H5, hydrogen, Br. Here I will replace the position, okay? The Br and the hydrogen. This isomer number A, B, C. Okay. Now also draw the mirror image for this isomer number 3. This the C. Draw the mirror image. This is the mirror image. Okay. Here the mirror image, C2H5, CH3, the Br, the hydrogen, Br with the Br, and the hydrogen with the hydrogen. This isomer number, D. Okay. Now, mirror image or not mirror image? Yes, mirror image. Okay. Superimposable, non-superimposable? Non-superimposable. يعني تشيا؟ يعني N enantiomers. Enantiomers. Chiral or achiral? Chiral molecule. So, now we have A with B, enantiomers. C with D, enantiomers. Okay? Now, what is the relationship between A plus C? Look, and you have to think. A plus C, they are mirror image? A with C, they are mirror image? Non-mirror image. Okay, superimposable or non-superimposable? Huh? Non-superimposable. Where is the difference? The difference here. If you put this compound on this compound, all the atoms, it will be aligned. Just with the hydrogen and the Br, we have a problem here. That meaning non-superimposable. Okay. A with C, not mirror image. Non-superimposable يعني chiral طبعا هي chiral molecules يعني this the second the new terms that meaning they are diastereomers طلبة they are stereoisomers, they are not mirror image, are non-superimposable. Okay, not mirror image. The difference between diastereomers and enantiomers mirror image, and this they are not mirror image. Okay, what is the relationship between A and D? A and D. Look, A and D. Put A and D beside each other like that. Okay, what is the difference? Where is the difference? They are mirror image? No. Also, they are not mirror image, chiral molecule, but also it will be diastereomers. Okay. Now, B with C. B with C. B with C. Okay, mirror image? Br here, hydrogen here, Br here. That meaning they are not mirror image. Stereoisomers, not mirror image. Superimposable, they are also diastereomers. Okay, now B with D. Non-superimposable. Mirror image or not mirror image? Non-mirror image. يعني diastereomers. So for this example here, we have two enantiomers, and how many diastereomers we have? We have 4 diastereomers. Okay, we have 4 diastereomers. Clear? Tamam. Now, what is the difference between diastereomers and enantiomers? Enantiomers, again, they are mirror image, superimposable enantiomers. Yes, chiral molecules. And the diastereomers, not mirror image, non-superimposable, stereoisomers, chiral molecules, but it will be what? It will be diastereomers, not mirror image. Okay, not mirror image. Okay. Look here. The pairs of the diastereomers, A with C, A with D, B with C, B with D, all this, they are diastereomers. And how many enantiomers you have? You have 2 enantiomers. Now label the 2 stereogenic center in each compound and draw the all possible stereoisomers. Okay? شو معنى label؟ يعني where is the stereogenic center here? Where is the stereogenic center here? Here. Okay, refer to the stereogenic center and draw all stereoisomers, يعني diastereomers and enantiomers. Okay? All stereoisomers. عشان enantiomer here, you have to draw the enantiomers. How many diastereomers you have it? You have to draw the diastereomers. Okay? For this example. Also for B. Now, another subject here, the meso compound. What meaning the meso compound? Okay, what meaning the meso compound? 2,3-dibromopentane, this compound, has two stereogenic center. Okay, here, stereogenic center number 1, stereogenic center number 2. And as we know, the maximum number of the stereogenic center is going to be what? 4. But this compound has three stereoisomers, not 4 stereoisomers, 3 stereoisomers. Why? We will be see here. No, the same procedure. You say the same procedure. Find or draw the stereoisomers for this compound. Okay, the same procedure. I want to change it. Yeah. Br. Here, what is the difference between this CH3, CH3? Yes. Look here. Hydrogen, Br, CH3. Yes. This also. 1, 2, 3. Okay. This is the isomer number 1 for this compound. Yes? For this our example. This isomer number 1. Draw the isomer number 2, the mirror image. Yes? It will be Br, hydrogen, CH3, CH3, hydrogen, Br. Mirror image or not mirror image? Mirror image. Okay. Super possible or non-super impossible? Non-super impossible. Okay. Chiral or achiral? Outdated. Chiral or achiral. Okay. Now, mirror image, non-super impossible. That meaning it will be what? In and show Mars. Good. Okay. I want to draw the third isomers. I have to switch the two groups, this with this, okay? Now switch the Br with the hydrogen. Here it will be Br, here it will be hydrogen, and Br, CH3, CH3. Okay, draw the mirror image, this A, B, this A, B isomer, this C isomer. Draw the mirror image, Br, this is the Br, hydrogen, hydrogen, and we have here CH3, and we have here CH3, Br, hydrogen. Look, mirror image, super possible or non-super impossible? هذا راكا وده very. Okay, put in each other like that. Super possible, ma? Super possible. Okay. C super possible to this compound. That meaning C and D, they are enantiomer? No. Super possible. Diastereomers? No. Diastereomers also non-super impossible. Okay, they are identical. They are same compound, identical compound. Yani C and D, the same compound, no different. This with this, there is no different. Okay, that meaning how many stereoisomers we have? We have A, we have B, and we have C. We have just 3 stereoisomers. A, B, C. Okay, look to the C. What is the difference between A, B, and C? What is the difference? Where is the difference between A and B and C? There is a clear difference between of them, if you can find it. Okay. Now, this chiral molecule, Bucci. What meaning chiral? Okay, go to the plane of symmetry. Do you have a plane of symmetry here? In this figure? No, if you put the plane of symmetry like that, this part not like to this part. If you put plane of symmetry here, this part, it will be the same to this part. That meaning there is, it will be different. That means there is no plane of symmetry. Okay? This meaning this chiral or achiral? Achiral. Or chiral? It will be chiral. Okay. Now go to the, put plane of symmetry. Do you have plane of symmetry here? No. Why? Because this part not like to this part. put a plane of symmetry here. Are this part like this part? No, that meaning there is no plane of symmetry. That meaning it will be chiral molecule. Chiral molecules, chiral molecules. Okay, go to this. Do you have a plane of symmetry here? Yes, that meaning this isomer here is achiral molecules, has a plane of symmetry. This, and it will be referred to the meso compound. What meaning meso compound? Meso compound, molecules that has a stereogenic center more than one stereogenic center, yani 2 or 3 or 4 or more than this, and that has a plane of symmetry, and they are achiral molecules. This is the meaning of meso compound. Okay? This is the meaning of meso compound. For this reason, I give you here, meso compound is achiral compounds that contain tetrahedral stereogenic center. Tetrahedral stereogenic center higher. Okay? Yes, they have stereogenic center, but they are achiral molecules, not chiral. Okay, this is the meso compound. Do you understand what is the difference between enantiomers, diastereomers, or meso compound? Okay, enantiomers, chiral molecules. Diastereomers, chiral molecules. Meso compound, achiral molecules. Why? Chunko plane of symmetry here. Okay? That enantiomers, they are non-superimposable. Diastereomers, also non-superimposable. Meso compound like this, C and D, identical compounds. Okay, the same compounds that has a plane of symmetry, it will be achiral. Achiral. Okay. Draw all possible stereoisomers for each compound and label pairs of the enantiomers and diastereomers. He said draw all the possible stereoisomers for this example here and refer to this isomers. It will be diastereomers or enantiomers. Okay? Which compound are meso compound? This or this or this? What do you think? This or this or this? Meso compound what we have? We have plane of symmetry. We have plane of symmetry here? Yes. Yes, that meaning this meso compound. Okay? Meso compound. And this? And this? Not meso. And this? Here? Do you think this meso compound or not meso compound? Do you have a plane of symmetry? Okay. At your home, I don't give you the answer. At your home, just you have to make rotation here. Make rotation and look, it will be meso compound or non-meso compound. Okay, it will be has a plane of symmetry or without a plane of symmetry. Just make rotation and then answer. Okay, and then answer. So draw the meso compound for each of the following molecules. He said, this molecules, I want the meso compound for this molecules. Yani to convert this structure to the three-dimensional figure like this, three-dimensional figure, but they has a plane of symmetry. Okay? Now where is the stereogenic center here? أبا دائما CH2 not a stereogenic center, CH3. Yes, we have a stereogenic center here. This, yes, we have a stereogenic center here. This, no. That means this molecules has two stereogenic center here and here. By this, easy. By this three-dimensional figure, put the groups until they has a plane of symmetry. Okay, until they has a plane of symmetry. Draw the meso compound for each this molecules. This two-dimensional figure, you have to convert the two-dimensional figure to the three-dimensional figure, and then must be has a plane of symmetry. This also two-dimensional figure, convert to the three-dimensional figure, and then put the plane of symmetry. Okay, put the plane of symmetry. Now the next lecture, inshallah, we will talk about ROS assignment configuration for the compound that has more than two stereogenic center, 2 or 3 or 4. Okay, how we can found the RS configuration, how many isomers they will have it. Inshallah, next lecture we talk about the S or R configuration for the molecules that has more than two stereogenic center, 2, 3, 4. Okay, do you have a question? Do you have a question? No question? Okay, see you.